Hello everybody. In the last class we have started our discussion about the manufacturing of PCBs. In that we have discussed 5 steps of manufacturing the PCBs, and in today's video we will discuss the remaining steps in the preparation of PCBs. So before going into the today's session, first we'll just brush up the things that we have discussed in the previous video. So as a part of manufacturing of PCBs, the first step is nothing but the designing of PCB, that is we'll be developing a blueprint with the help of a software called extension Gerber software, and this will be once checked and next move to the other stage, that is nothing but the printing of the PCB design. So based on the layers and all, the selection of the ink will be made, either black ink or clear ink will be made, and for the inner layers and the outer layers PCB printing will be done. For the inner layers one kind of PCB, one kind of ink, and the other kind of ink for the inner layers will be done. And the second step is a printing of the copper for the interior layers. That is nothing but once the second step has been completed, a copper will be placed on the laminate, and the copper is etched away after the blueprint and all, and next photoresist material has been placed on the copper coating, which is tightened with the help of ultraviolet light, and then it is washed off with a any chemical substance like alkaline material. It is washed, and after drying it will be checked, and it will be sent for the, and if there are no errors, then it will be sent for the next stage, that is getting rid of unneeded copper. In this stage what we do is that we remove the unwanted copper which may get coated on the extra surface that is available on the PCB. That will be etched away using an powerful alkaline solution, and after that the photoresist which we have incorporated with the help of ultraviolet red, that will also be removed in this step. And in the fifth step what we have discussed is in the inspection and layer alignment, optical layer alignment. What we do is we simply with the help of an optical punch, the alignment will be done, and the optical punch will drive the pin through the holes to line up the layers of the PCB. After the optical punch, what we do is that when we find that there are no defects, the optical inspection will be done for any errors that can be which cannot be corrected in the previous stages. This will be corrected with the help of optical inspection. So to confirm that there are no errors, an AOI machine compares the PCB that to be inspected with the software which is prescribed by the manufacturers. So after the PCB has passed the inspection in the fifth stage, that is neither the technician nor the AOI machine founds any defect, it moves to the next stage, and that stage is nothing but the lamination of the PCBs. So the sixth step of the PCB manufacturing process is the lamination. So the PCB layers are all together now waiting for the lamination. Okay, once the layers have been confirmed as being defect free, they are ready to be fused together. Till now, right from the second step to the fifth step, right in the second step we have done for the error correction has been done, and the fifth step also we have checked for errors optically, and also with the help of a machine error detection has been done. And now as we find no errors, now it is being error free, the PCB is ready to be fused together. That is all the films what we have prepared is ready to be fused. The PCB lamination process will be done in two steps. That is, first step is layup step and the second one is laminating step. So it will be done in two steps, layup step and laminating step. The outside of the PCB is made up of pieces of fiberglass that has been pre-soaked or pre-coated with epoxy resin. The original piece of the substrate is also covered in a layer of thin copper foil that now contains the etchings from the copper traces. Once the outer and the inner layers are ready, now it is the time to put them together. That is, we just push them together. The sandwiching of these layers is done using metal clamps and special press table. Each layer fits on the table using a specialized pin. The technician, what he is doing is, he'll be doing the lamination process. Starts by placing a layer of pre-coated epoxy resin known as pre-impregnated or pre-pregged on the alignment basin on the table. A layer of the substrate is placed over the pre-impregnated resin, followed by the layer of the copper foil. So the copper foil is in turn followed by more sheets of pre-impregnated resin, which are then finished off with a piece of one ore, and one last piece of copper is known as press plate. Okay. Once a copper press plate is placed, the stack is ready to be pressed. So what we'll be doing is that we'll be stacking all the required films including the copper plate, and now this whole stack is ready to be pressed. Now a mechanical press will be done on the layers and all the layers will be put together. As a part of this process, the pins are then punched down through the stack of layers to ensure that they are fixed properly. If all the layers are fixed properly, the PCB stack is taken to the next press, that is a laminating press. Okay. So the laminating press uses a pair of heated plates to apply heat and pressure to the stack of layers. The heat of the plates melts the epoxy inside the pre-peg. It is a pressure from the pressure combined to fuse the stack of PCB layers together. Once the PCB layers are pressed together, there is a little bit of unpacking that needs to be done. Okay. The technician now needs to remove the top press plate and the pins, which then allow them to pull the actual PCB free. So as of now, all the layers have been stacked up, on which the top layer will be using a press plate, and pins have been used to put them all together. After the lamination process is completed, what we do is that we remove the top press plates and all the pins which we have held in the PCB will be removed and will be sent to the next stage of manufacturing. So the next stage of manufacturing is nothing but is drilling. So the seventh stage is nothing but drilling. So before we go into the drilling process, an X-ray machine is used to locate the drill spots. Then the registration holes are drilled so that the PCB stack can be secured before the more specific holes are drilled. When it comes time to drill these holes, a computer guided drill is used to make the holes themselves, using the file from the software design as a guide. Okay. So with the help of uh, computer guided drill, that too which is available from the software what we use for the PCB manufacturing, will help in drilling the holes by themselves with the help of the software. Once this drilling process is complete, the additional copper that is left over at the edges is filed off. Okay, this is how we do drilling. So even the drilling will be computerized only. So once we, in the first step of PCB manufacturing, that is designing of PCB itself, the drilling part, that is where we need to incorporate the components, will also be decided. So the copper tracks, as well as that is copper coating, as well as the drilling will also be guided in the software itself. So once it is decided in the first step, that will take the help of the first step in the second step also. And the next step is PCB plating. Eighth step is PCB plating. After the panel has been drilled, now the PCB is ready to be plated. The plating process uses a chemical to fuse all of the different layers of PCB together. Okay, plating is nothing but with the help of a chemical we fuse all the different layers of the PCB together. Okay, for this to be done, cleaning should be done thoroughly. That is, after being cleaned thoroughly, the PCB is bathed in a series of chemicals. Right from the step 4, the cleaning process will start. So again, after being properly and thoroughly cleaned in chemical solvents, this fusing of or the plating process will start. The part of this bathing process coats the panel in a micro thick layer of copper, which is deposited over the topmost layers and into the holes that have just been drilled. Okay, before the holes are drilled with copper, they simply serve to expose the glass substrate that make up the panel inside. So bathing these holes in copper covers the walls of the previously drilled holes. What happens here in the plating is here in the plating process, what we do is we fuse all the different layers of PCB together with the help of chemicals. And before this plating procedure, we have done a process called as drilling. When we drill the substrate, when holes are being drilled, we observe that on the inside the holes what we drill, those holes will not be of conducting layers. So there will be just epoxy resin or glass type of PCB will be available. So when we place components, those components should be able to touch the copper. So for that, what we do is that in the plating process, that is in step 8, even these holes will be filled with copper. So the filling of the holes with the copper will be done in the plating step. So the plating step uses a chemical to fuse all the different layers. So for this to be done, so this PCB will be bathed in several chemicals. So after this step, we'll be moving into the other step, that is nothing but imaging and plating the outer layers. So even in the step 3, a photoresist was applied to the PCB panel. And in the step 9 also, it's time to appear another layer of photoresist. However, this time the photoresist is only applied to the outer layer, since it still needs to be imaged. Once the outer layer has been coated in photoresist and imaged, they are plated in the exact same way the inner layers of the PCB were plated in the previous step. However, while the process is the same, the outer layer gets plating of tin to help guard the copper of the outside layer. So this stage of step 9 and 10 are same as that of step 3 and 9. Okay, the thing is that this process, in this step, what we do is that outer layers of the PCB will get a plating of tin just to protect the copper from the outside layers. Okay, so the same thing we do. Thing is that we coat it on the outside outer layers of the PCB with tin. So that is nothing but imaging and plating of the outer layers. After this has been done, already once we have done etching in the third step, again we repeat here, that is the last etching we call. The 11th step is nothing but the last etching. When it comes time to etch the outside layer for the last time, the tin guard is used to help protect the copper during the etching process. So this tin what we have used in the previous stage, that is 9 and 10 stage, will help in protecting the copper during the final etching process. Any unwanted copper is removed using the same copper solvent which we have used in the etching process, what we have used in the previous stages, with the tin protecting the valued copper of the etching area. Okay, so once the overall copper is removed, the PCB connections have been properly established and it is now ready for solder masking. Okay, na? Till now on the substrate we have done everything what we can do, starting from the designing part to the final etching. We have taken up to some 11 stages in the manufacturing process. Till now, what are all the things that we can do to a substrate has been done. Now we'll move on with the second main part of the PCB, that is nothing but solder mask. So now we'll see what this solder mask will do. So while I was telling you about the solder mask in the previous video, I told you that solder mask is nothing but a protective layer, that is which for example, if we take skin that protects our body, likewise solder mask is a thing that protects the PCB from the outside environment and also protecting the inner copper tracks or the inner layers that we have developed. Okay, now the 12th step is nothing but protecting stage, that we simply say it as, that is nothing but applying the solder mask. To make the panels ready for the solder mask application, first they are cleaned. Okay, so once the PCB panels have been cleaned, an ink epoxy is applied along with the solder mask film. Okay, the boards are blasted again with ultraviolet to mark out the certain portions of the solder mask for removal. After the unwanted pieces of these solder masks have been removed, the PCB is placed into an oven and baked so that the final mask will cure. Okay, so in the solder mask stage, cleaning will be done and an ink epoxy application along with the solder mask will be made, and then it will be exposed to ultraviolet rays. After that, unwanted pieces of solder mask will be removed, and now after the removal of the unwanted solder mask, PCB will be placed in an oven and baked until the solder mask will cure. Okay, this is the 12th stage. And coming to the steps 13 and 14, the final step is nothing but the finishing the PCB and silk screening. So the silk screening is a term which we have already discussed. Silk screening is nothing but the fourth important part of a PCB. So silk screening is usually on the component side of the board, and it is used to show the part numbers, logos, symbols, component frequency and test points. So silk screening, what we have initially what I have told you initially was, silk screen is nothing but a nomenclature, like what are all the things that we place on the PCB, including its numbers, logos, etc. It is nothing but silk screening. So the 13th and 14th step are nothing but finishing of PCB and silk screening. So you know what is meant by silk screening, that will be done here. Okay, as a part of finishing process, the PCB will be either coated with gold, silver, so that the components are able to be soldered on the pads created and to protect the copper. Okay, so final coating either with gold or silver will be done for the protection of the copper. After PCB has been gold or silver plated as necessary, it is now silk screen. Silk screening process prints all the vital information on the PCB. Okay, so just now I was telling you that, such as manufacturing marks, company IDs, logos, component numbers, warning labels, etc. will all be printed, and that printing is known as silk screened. So once the PCB has been plated and silk screened with the correct information, it can be sent along to the final curing stage. Okay, so once it is done, it can be sent to the final curing stage. And the next step is nothing but 15th step, electrical reliability test. So this is one of the important thing that we have to check, so that the PCB is ready to be used and that PCB is accurate in its operation will be, its accuracy in operation will be decided in this test, electrical reliability test. So after the PCB has been coated, and if it necessary, and after curing, a technician performs a battery of electrical tests on the different areas of PCB to ensure the functionality. Till now we have been placing the copper layer and protecting the copper layer and all, but the functionality has not been tested till now. So a technician now, he'll be test after the silk screening, the technician will test on the different areas randomly to ensure the functionalities. The main tests that are performed are circuit continuity and isolation tests. So the main tests are continuity test and isolation test. The circuit continuity test checks for any disconnections in the PCBs known as open. So as the name suggests, continuity test will check for any discontinuity in the PCBs. The circuit isolation test, what does it do is, it checks for the isolation values of the PCBs various parts in order to check if there are any short circuits. So if there are any disconnections, it will be checked in the continuity test, and if there are any short circuits, will be checked in the isolation test. So these two tests will be done by the technician randomly. Okay na? While the electrical tests mainly exist to ensure functionality, they also work as a test of how well the initial PCB design stood up to the manufacturing process. So not only to ensure the functionality, the other advantage of carrying out this electrical reliability test is that how well our PCB is able to withstand all the process which we have taken the PCB through, like right from the second step, that is from uh, printing stage up to the stage of screen printing, silk screening. What are the PCB has been uh, exposed to several chemicals and exposed to ultraviolet rays, exposed to drilling thing and all. So after all these things have been done, how well our PCB is now performing will be tested in step 15, that is electrical reliability test. That is, this test not only ensures the functionality, but it also tells us or show us how best our PCB has withstanded all these processes, and it is able to show the main functionality which it was designed to be. Okay, so how well the initial PCB design stood up to the manufacturing process will be checked in this stage. Okay, in addition to this basic reliability testing, there are another tests also that can be used to determine if a PCB is functional. Okay, like continuity test, and in addition to continuity and isolation test, we can also conduct some other tests to check the PCB functionality. So one of the test is named as bed of nails test. Okay, bed of nails test. During this test, several spring fixtures are attached to the test points on the springboard. The spring fixtures then subject to the test points on the circuit board up to 200 G of pressure to see how well the PCB stands to high pressure contact as it tests as its test point. Okay, so we'll be conducting isolation test, continuity test, and as well as bed of nail test if necessary. So with this, or with all these tests, the technician will be able to know the functionality and the and and also how well our design stood up for all the stages of the manufacturing process. So after the PCB has passed its electrical reliability test, if needed, the technician can also choose any kind of test, or the manufacturer also choose, if needed, if they want, they can also conduct any other kind of tests that are that can show the functionality of the PCB. And after all the tests have been completed, now PCB now moves to the next stage, that is nothing but cutting and profiling. So cutting and profiling is nothing but the last stage of PCB manufacturing. So the last step of PCB manufacturing is nothing but cutting and scoring of the PCB. So this involves the cutting out of the different PCBs from the original panel. There are two ways that a PCB can be cut from their original panels. Either we can use a CNC machine or a router which cuts out the small tabs around the edges of the PCB, or otherwise we can use by using a V groove which cuts a diagonal channel along the sides of the board. Either by using a CNC machine or with the help of a V groove, we can cut the PCB according to the requirement. Usually PCB panels have individual boards or larger or larger arrays, if applicable, rooted out and scored so they can be broken off of the construction board after they have been assembled. Okay na? So this is nothing but the last step, that is PCB in the PCB manufacturing, that is cutting and profiling. So any of the ways you can cut the PCBs. And coming to the final steps, that is once the boards are broken off of the main construction board, it comes the final inspection phase. So once the boards are checked over the general cleanliness and to ensure that there are no sharp edges, blurs or any other manufacturing hazards. Next, slots, bevels, countersinks are added during the routing and fabrication process if necessary. If possible, any shorts are repaired. The shorted boards are then retested using some electrical reliability tests from which we have discussed above. A visual inspection can be conducted if necessary to ensure that the boards meet the industry specification and match up the details laid out in the software. Okay, the technician can also use the visual inspection to verify the hole sizes and the physical dimensions of the PCB if required. So these steps may or may not be done, but these steps will help in bringing out a perfect and an accurate PCB into the market. So altogether, these, once a PCB is coming out, we can say that the PCB is going through all these 16 steps in order to get out, or in order to bring out a perfect working PCB. Okay. So with this, we got to know how a what is all about PCB and types, what are the main parts of PCB, and also the various steps that have been involved in the process of manufacturing of PCB have been discussed. Okay, so with this, we'll stop our discussion of PCB manufacturing process. Thank you.